Hello students, let's see Faraday's law of induction. Faraday stated experimental observations in form of law which is called Faraday's law of induction, and it gives what magnitude of induced EMF and direction of induced EMF is given by what Lenz's law, which will be see in our next lecture. Now let's see Faraday's law of induction. So here we can say Faraday stated experimental observations in form of law called Faraday's law of induction, which gives what? Which gives magnitude of induced EMF. So we can say Faraday's law gives what? Magnitude of induced EMF. So the law stated as the magnitude of induced EMF, the magnitude of induced EMF in a closed circuit, magnitude of induced EMF in a closed circuit is equal to negative of time rate of change of magnetic flux, time rate of change of magnetic flux through the circuit. Okay, in experiment number 1, 2 and 3, okay, we derived some common results and we see that the relative motion between the bar magnet and coil, or you can say relative motion between the two coils, is not necessary to induce the current in a coil, but the necessary requirement is what? Change in flux through the coil with respect to time. So that change in flux with respect to time gives us what? EMF, and that EMF, okay, it is the reason to induce the current in a circuit. Means we can say current is produced, or you can say induced in a coil due to what? Induction of EMF. So here we can say the magnitude of that induced EMF in a closed circuit is equal to what? Negative of time rate of change of magnetic flux through that closed circuit. Okay, so here mathematically we can say magnitude of, we can say, induced EMF is equal to what? Minus d phi by dt. Okay, mathematically we can say E is equal to what? Minus d phi by dt. Okay, और अगर टाइम इंटरवल स्मॉल नहीं है, हम लोग एवरेज EMF लिखे तो आप लिख सकते हो E is equal to what? Minus del phi by del t. Okay, here this negative sign indicates what? Direction of induced EMF, okay, which will we see in our next lecture in the Lenz's law. So here we can say here negative sign indicates direction of induced EMF given by Lenz's law. Okay, now here you can see that in delta t time change in flux is delta phi through the closed circuit, then we can say magnitude of induced EMF is equal to what? Minus del phi by del t. Okay, but if this coil have n number of turns, then what happens? If coil has n turns, and flux linked with each turn is phi, then total flux, we can say total flux is what, n phi. Okay, now here we can say if rate of change of flux through each turn is same, if rate of change of flux through each turn is same, then total induced EMF, अब हमने यहाँ पे बोला कि रेट ऑफ चेंज ऑफ फ्लक्स हर एक टर्न में क्या है, सेम है, ठीक है, एन टर्न्स है, टोटल फ्लक्स कितना है, एन फाइव, हर एक में रेट ऑफ चेंज ऑफ फ्लक्स कितना है, सेम है, तो ईएमएफ कितना होगा, देन टोटल इंड्यूस्ड ईएमएफ इज इक्वल टू, वी कैन से डी बाय, और यू कैन से डेल बाय डेल टी ऑफ व्हाट, एन फाइव, टोटल चेंज इन फ्लक्स हो गया ये, ठीक है, तो आप इसको लिख सकते हो एन डेल्टा फाइव बाय डेल्टा टी, ओके, और आगे नेगेटिव साइन एज इट इज विच इंडिकेट्स व्हाट, प्रेजेंस ऑफ लेंस लॉ, ओके. नाउ हियर वी कैन से इफ delta t tends to 0, okay, then we know that if delta t tends to 0 we get what, instantaneous EMF, then EMF is equal to, I can say, limit delta t tends to 0 minus n del phi by del t, and it becomes what, minus n d phi by dt. So here we have the magnitude of instantaneous EMF, okay, produced in a coil having a n turns.